changes, I guess, when we move from motion in one dimension to motion in two dimension is the fact that we literally are adding in an extra dimension, and that means that we need to look at these things called components. So previously we've previously been looking at motion that was either sort of like side to side, side to side, or up and down by nature. Where now we're going to be looking at things that are more realistically sort of representing this idea of a parabola. And what that means is that motion is going to be occurring on some sort of angle, and because of that, it's going to be broken into components. So let's say, for example, that this object, if this is sort of like the ground here, we're going to say that this object has been launched at an angle of 30 degrees, and you can see that it's going to follow that sort of parabolic shape in its motion. Now, if I really sort of examine what's actually happening here and I blow this up, what I'm saying is that this is the velocity of the object and it's occurring at a 30-degree angle. Now, if we're sort of really analysing what's happening here, what we're saying is that there are two components that are making that velocity go on that particular angle. One of them is referred to as Vx and the other as Vy. Just so you're aware, you might see in some textbooks or online that it might be represented by Vh and Vv, and that would be representing the words horizontal and vertical. However, X and Y are also fine, and that's sort of what I'm going to be using for these videos. Now, hopefully you can see that when I've drawn up this triangle, I've got clearly a right angle triangle that we're dealing with. And if I asked you using trigonometry to tell me what Vx is equal to, then hopefully what you would say is you'd go, okay, well, Vx here is the adjacent side to 30 degrees and V is the hypotenuse. So therefore, if I was looking at using trig, I'd say cos of 30 equals the adjacent, which is Vx, divided by the hypotenuse, which is V. So therefore, V times cos theta, or cos 30 in this case, is equal to Vx. Now that will happen every single time you do one of these questions. And what the key takeaway for that is that Vx is equal to V cos theta. So that is how we can find what we would call the horizontal component, or the x component, of that velocity. Now likewise, if I'm trying to find Vy, what we would say is that Vy is opposite to 30, so therefore sine 30 is equal to Vy divided by V, and therefore very similarly, V times sine 30 is equal to Vy, and therefore, I'm not sure why that's happened, Vy is equal to, whoa, you've got a lot of stuff going on here. Let me just tidy that up a little bit. Maybe I can't. Let's just scroll down here. Whoa, it's going with me. That's crazy. Let me try this. Oh dear. Anyway, I'm just going to crack on. So what I'm going to say here is that Vy, I'm going to say Vy, oh there we go, Vy is equal to sine theta. So we've got two really important takeaways that are occurring out of this. We've got Vx is represented by V cos theta, and Vy is represented by V sine theta. So if you've got a question they're asking you about the components of velocity, that's really what it's asking you to do, is to break down what that would represent for us. It's important that when you are doing this, that in your calculator you have a calculator set to degrees and not set to radians, because we are dealing with degrees in physics, and that's going to make life a lot easier for you, and it will ensure that you are correct with what you are doing. Now, there's a couple of other things to be aware of with what we're sort of looking at here, and that is, if you sort of look at how this motion transpires, it is going to be sort of parabolic motion. And if we really try and break this down, what we're saying is that for this here, there is a Vx and there is a Vy. Now, we know that gravity is clearly working downwards in this scenario, and that's why we see the object going up and then going down. What that means is that the Vy component is going to get smaller and smaller as it goes up, to the point where it's actually 0 at the top here, and then as it goes down, it's going to slowly increase until it gets to a larger value. Now, because gravity is working down, and again, if we're assuming that there is no air resistance here, then what we would be saying is that at the moment, nothing is actually affecting Vx. And because of that, Vx is actually consistent. Now, what that means for us is, if you sort of go back and look at the equations of motion that we looked at, we had one equation which was S equals Vt. And we said that that equation was only relevant when you had a constant velocity or an average velocity. Now, in this scenario, we have exactly that for Vx. So we can actually say that S is equal to Vxt, and that would be a horizontal distance, and the word that is commonly associated with that is range. So range is representing the horizontal distance that the object is actually moving as a result of the time of flight, which is t, and also Vx, which is the horizontal component of the velocity. So that's the process that we're looking through there for the components. Vy is going to be looking at things like maximum height and also time of flight. So knowing the components is very, very important because it will allow us then to solve some more complex questions in 2 dimensions.